Hello everyone, today we are together again with you to solve a first order linear differential equation, an initial value problem in fact given as dy over dx plus 3y over x plus 2 equals 3x with initial condition y of 1 is equal to 1. In fact, I have taken this question from Kent Nagel's book. Let me write it. And let's start the solution steps. Since we know that while solving an initial value problem, we first the differential equation, then we apply the initial condition to be able to define the parameters, the constant parameters. In fact, the differential equation, this differential equation is a first order differential equation and a linear differential equation when we collect the terms of the terms containing not dependent variable to the right hand side of the equation, we find dy over dx plus 3 over x times y equals 3x minus 2. Now we see that the term dy over dx is here and the coefficient of the dependent variable y is p of x, and the right hand side is the function of the independent variable x, let's say q of x. Thus we see that this equation and a first order linear differential equation, and here we are going to solve this equation by using integral factor method, and we know that the integration factor mu of x equals exponential integral of p of x with respect to x. So we see that p of x equals 3 over x, then I just substitute the function p of x here, exponential integral 3 over x dx, and it is easy to see that exponential 3 times integral 1 over x dx, and that is equal to exponential 3 times ln of x, and that is going to be equal to exponential ln of x cube. Thus we find the integral factor mu of x equals x cube. When we multiply both sides of the equation with integration factor mu of x times dy over dx plus 3 over x times y equals mu of x times 3 times x minus 2. Then when I substitute x cube here, let me write x cube times dy over dx plus x cube times 3 over x times y equals x cube times 3x minus 2. Let me delete this parenthesis. And when I rearranged the left hand side of the equation, I write x cubed times dy over dx plus 3 times x squared times y equals 3 times x to the power 4 minus 2x cubed. Now, let me check the left hand side of the equation. In the first term, one of the components is x cubed, and I see that at the right hand side, and at the other term I find the derivative of x cubed here, derivative of x cubed, and the other term y, and I see that the derivative of y here. So the left hand side of this equation can be written as d over dx y times x cubed. The derivative of y times x cubed with respect to x equals, again, 3x to the power 4 minus 2 times x cubed. Okay, now time to integration. When I integrate before, or let me send the dx to the right hand side. The y times x cubed equals 3x to the power 4 minus 2x cubed times dx. Okay, and integrating now both sides of this equation, then the left hand side is going to be y times x cubed equals, and the integration of the right hand side is 3 times x to the power 5 over 5 minus 2 times x to the power 4 over 4 plus c. Here c is constant of integration. Constant of integration. C. So now I'm going to determine the dependent variable, in fact the solution of the problem. Y of x is equal to 1 over x cubed times 3 over 5 x to the power 5 minus 1 over 2 times x to the power 4 plus c. And in fact, this is the solution of the first order differential equation, but since the problem is an initial value problem, I have to find also the exact value of c. So in fact the condition is given to me to be able to determine c. So I know that the initial condition y1 is equal to 1 means, that means when x is 1 here, that means when x is 1, then y also equals to 1. This one is this one. So I'm going to use this property to be able to determine c by substituting these two values into the solution. So y1, I will substitute x is 1 and y is 1 in the solution. So y of 1 equals 1 over 1 to the power 3 over 5 times 1 to the power 5 minus 1 over 2 times 1 to the power 4 plus c, plus c. So when I calculate, since I know that y of 1 is also 1, here I can easily find c as 9 over 10. So this value tells me that when I substitute it in the solution, I'm going to find the solution of the initial value problem given above is equal to y of x is equal to 3 over 5 times x squared minus x to the power x over 2 plus 9 over 10 x cubed. This is the solution of the initial value problem.